Hey Stats class, in this video we're going to be looking at the setup and the carrying out a hypothesis test about a mean. So the first thing we're asked is the setup. What's the null and alternate hypothesis? So you're looking at the statement of a claim here, and so this is the one that we're looking at. Test the claim that the population standard student course evaluation has a mean equal to 4.25. So it's specifically equal to. It doesn't imply a direction. It doesn't give us a greater than or less than. It just is straight up equal to. So this is the null hypothesis, and so since they don't imply a direction, the alternate is going to be not equal to. So you can see that's the reason why D is the correct answer here. And now going on to the next one, determine the test statistic. So this is where you're going to bring in Desmos. So what you're going to do here is you're going to start off with division, and you want the sample mean, which is 4.18 here, and you're going to subtract the claim value of the population mean. So that's this 4.25, and then you're going to divide by, you need a fraction down here, and then S, the sample standard deviation, is 0.52, and then you divide that by the square root SQRT of your sample size, and our sample size is 90 here, so I'll put 90 underneath there, and so there's our test statistic. So sample mean minus population mean divided by sample standard deviation over the square root of the sample size. So negative 1.28 to two decimal places, negative 1.28. All right, and then the next thing it wants to know is find the p-value. Now when you're doing a p-value, you want to use the t distribution here. This is t dist, and t dist wants to know the number of degrees of freedom. So our degrees of freedom again is one less than our sample size, so sample size of 90 will have 89 degrees of freedom. The shift that it's asking for here is the population mean. So the claim population mean is 4.25. So I'll put that in there, 4.25. And then the standard deviation is what we use for our scale. But remember, it's the standard deviation of the sample mean. So it's the 0.52 divided by the square root of 90. That's what I used right here in the last problem. So I'm going to just grab it and paste it in there. But you just type that in there again if you needed to. Okay, now this is a sample mean that's below the claim mean. So I'm actually going to go into the left tail here. So I would select left. Mine's already selected. And then the number I'm going to pick here is the sample mean, the 4.18. So there is the probability of being at 4.18 or lower in the left tail. I'm going to grab this number and just drop it down here. And then I'm going to double that. So 2 times that number is my p-value. So around the 3 places, that'll be 0.205 is the p-value of that test statistic. All right, I do want you to see that I do have another way that I could find that p-value, and it's without doing all this stuff right here. You just do your t distribution and TDIST. You still give it your degrees of freedom. You got to have the degrees of freedom in there, but I'm going to close that off. And then I'm going to come down here and I'm going to do cumulative probability, and instead of inner, I'm going to do outer, and because this was my test statistic, the negative 1.28 that I rounded to, I'm going to put that here on the lower one, the left one, negative 1.28, and then for the upper one, I'm just going to change that to a positive, so positive 1.28. And you'll see there's that same value that I got up here. Now the only difference in these is like the procedure, so you can see this would be 2.04, this is 2.05. The reason why they're off, number one, is because I rounded. If I would have used all of this instead of rounding it, it would have more values. And the upper one, the same thing. I just paste it in there, but then I'm going to take the negative sign away because I'm pasting a negative number. So there is that. Okay, and there's the value that I'm getting. Again, you can see it's much more accurate. Not necessarily more accurate, but much closer to what I had before when I wasn't having to round the values. So anyway, that is that's the other way that you could do it. And the thing I like about this one, let me zoom in around on this one, take the other one away, is it's, you know, it counts. There's 2 tails. You can see that it's a 2-tail test when you do it that way. With you do it the way that I mentioned before, you're only putting that value into the left tail, and then you have to remember to double it. But here, if you remember outer and just put the degrees of freedom in there and your test statistic, then you'll be able to see the p-values. are in two tails. So it looks like a two-tailed test. All right, our alpha, the level of significance is 0.05. This is bigger than that. So when your p-value is larger than alpha, you're going to fail to reject the null hypothesis. And if you fail to reject, it's because there's not sufficient evidence to support the alternate value. All right, the alternate was it's not equal, so that's the one that you don't have evidence for.